Valkey turns 1. How the community folk left Redis in the dust. Valkey is not only thriving but now outperforming Redis 8.0 in real world benchmarks. A year ago, Redis Inc., formerly Granatia Data, made a controversial move that disrupted the open source ecosystem. It closed the source of Redis. As I wrote at that time, it was a trust breaking decision that could have shattered the community, but instead of splintering, the community responded with purpose. Out of that disruption came Valkey, a fork that took a shot at keeping the community alive. A return, a reversal. As part of efforts to rebuild trust with the community, Redis Inc. brought back Salvatore Snafilio, aka Antares, the original creator of Redis. I am genuinely excited about this return because it is already impactful. He's following through on the promise of contributing new features and performance optimization to Redis more profoundly. Redis 8.0 has been open source again. Redis acknowledged that adopting SSPL strained their bond with the community, questioning contribution from others in the same breath. The disheartening move from Redis Inc. catalyzed an unprecedented wave of collaboration and contribution. Valkey became the test of the community resolve to keep itself together. 1 year later, Valkey hasn't just survived, it's thriving. The async IO threading model contribution from AWS unlocked 3x plus throughput by fundamentally changing how IO thread works inside Redis. But how do this and other contributors compare to Redis set? Can we hit 1 million RPS out of an 8 vCPU instance on either Valkey 8.1 or Redis 8.0 with 1 KB items, 3 M items in the key space, and 500 connection? It's time for a bake off. Valkey 8.1 versus Redis. Can the folk outrun the source? The punchline: we could not sustain 1 M RPS on a 8 vCPU instance with either Valkey or Redis 8.0, but we got really close. On a fully tuned C8G.2 XL 8 vCPU, Valkey 8.1.1 pushed to 999.8K RPS on SCTs with 0.8 ms P99 latency. Redis 8.0 got as high as 729.4 RPS on SCTs with 0.99 ms P99 latencies. On each iteration, we tested 50M SCTs followed by 50M GETs. We varied connection counts to optimize the maximum throughput for each system. Valkey achieved higher throughput and lower latency across both reads and write, 37% higher on SCT, 16% higher on GET, alongside 30% faster 9 P99 latency for SCT and 60% plus faster on GET. Threading, the multi-threading needle. If I had a penny for every time heard, but Redis Valkey single-threaded. Andres' emphasis on a shared nothing architecture has been foundational for Redis. Nevertheless, as early as 2020, Redis cited support for IO threads. Unfortunately, they did not offer drastic improvements until recently. If they had previously tried and discarded IO thread, it is time to evaluate again. On Valkey, we see set throughput going from 239K RPS without IO threads to 678K with 6 threads. Meanwhile, P99 latency dropped from 1.68 ms to 0.3993 ms despite doing nearly 3x the throughput. Similarly, Redis went from 235K RPS without IO threads to 563K RPS with 6 IO threads. P99s for Redis also dropped around 40% from 1.35 ms to 0.84 ms. Two key takeaways emerged. With 2 threads, gains were modest, 20%. The impact only really surfaced at 3 threads and beyond. Redis and Valkey were neck to neck until the 4th thread. After that, Valkey pulled away sharply. SAT performance on Valkey with IO threads and 256 connections. SAT performance on Redis with IO threads and 256 connections, pushing Valkey throughput further. In the previous section, we saw that Valkey could hit 678K RPS on SATs with 6 threads and 256 connection. If we up the connections to 400, the throughput goes up to 832K RPS. We used Regulus, our favorite Linux performance telemetry agent, to get deep insights into the system under stress. You can see in the charts below that overall CPU utilization is around 80% and unevenly distributed across the 8 core. Diving deeper, this is driven by hardware interrupts from network queues across all 8 cores. Interrupts are bad because they disrupt a hard working Valkey thread to yield to handle network packets. What if we could avoid the context switching on our 8 C8G.2XL with 8 cores running close to a million RPS requires considerable packet processing horsepower. Luckily, since a lot of work happens at the nitro level on EC2 instance, 2 allocated cores to IRQs is all you need if you let them focus. Pinning the IRQs to 2 cores is pretty straightforward, but how do we let this thread focus? And how do we avoid Redis and Valkey threads contending for the same cores? We pin Redis Valkey to cores 3-8, giving their IO threads better isolation while also allowing the IRQs to focus. We use the CPU set CPU's Docker flag to set the CPU assignment, making sure that Redis and Valkey process stayed pinned to the intended cores throughout the test. This reduces cross-core contention and improves cache locality, both of which are critical for minimizing tail latencies at high throughput. Ideal core allocation can vary in multi-tenant environment or mixed workloads, but in this benchmark it provided clean isolation between system and application workloads. Let's see what Resilius has to say about the new setup with IRQs pinned to the first 2 cores and Valkey pinned to the remaining 6 cores. First, we observed meaningfully higher CPU utilization. Second, looking at the bottom chart, soft IRQ, we see that it is now limited to only the first 2 cores. Third, the Valkey cores are running red hot, whereas we previously saw a much more scattered distribution, one usage across cores. While this setup is ideal for this benchmark, optimal IRQ tuning depends heavily on NIC architecture and the concurrency model of your application. The extra 20% CPU utilization is what buys us the extra 167K RPS from 832K RPS to 999.8K RPS. Try it yourself and know before you go. These benchmarks are hopefully a beginning and not the end. Our hope is that this sets up both Valkey and Redis community to continue the performance improvement journey. We also recognize that many folks may want to reproduce the benchmark in their own environments, incorporating their workflow specific. Below, we outline some key instructions that you can use to reproduce this on your AWS account within an hour. Instance type, we use AWS Graviton 4 based C8G instances launched in September 2024. The C8G2X large server node provides 8 vCPUs costing roughly $250 per month in US East 1, while the C8G 8X large load generator offers 32 vCPUs. This provided enough CPU headroom to cleanly isolate the benchmark workload, IRQ handling and Redis Valkey processing. The same C8G2XL instance was used to run Valkey and Redis one at a time. The same load gen node was run each time. Valkey and Redis were restarted right before each test to ensure fairness. Placement groups, we used EC2 placement groups cluster mode to ensure minimal network jitter and low latency communication between client and server nodes. Placement groups offer extremely tight latency by reducing the number of hops between your EC2 instance. This has the upside on higher throughput, fewer interruptions and lower latency, but it has some shared fate blast radius implications that are worth considering before deploying them in your production environment. Core pinning, to see the highest throughput and lowest latency, consider core pinning and reducing the IRQ. See section above for specific instruction we use on our 8 core instance. It is also important to apply similar techniques on your test nodes. Vary the connection count is surprisingly crucial variable for both Redis and Valkey. In fact, latency rises steeply as you approach 1024 connection on both of them. For example, going from 400 to 1024 connection, Valkey set throughput dropped from 999.9K with 2969K RPS and 9 P99. Latency doubled from 0.8 millisecond to 1.6 millisecond at 2048 connections. P99 latency triple, going from 384 connections to 1024. Redis throughput drops from 729.4k RPS to 668k RPS, and P99 latency more than double from 0.99 ms to 2.5 ms. Lower throughput with higher latency. You get why connection count tuning is so crucial here. Key space: if you want best number, use smaller values and a really small key space. Minus r 10,000. This will help you get everything from L3 cache. To make this test slightly more real world, we use 1KB items. Minus D1024 and a key space of 3 million. Multi-thread the benchmark app to get maximum throughput out of Valkey benchmark. Make sure to turn on multi-threading on the benchmark tool as well. The dash thread 6 flag tells Valkey benchmark to run in multi-threaded mode. A final caveat: benchmarking is imprecise in nature. We made every effort to make this benchmark resemble more real world workflows, but you can always do better. Valkey bench is not perfect, nothing is. We have a wish list of improvements, and so does the Valkey project. First, today it simply pushes as much load as the server is able to handle. Instead of targeting a particular TPS, the real world rarely modulates its throughput based on your latency. Second, once it can target specific load, it would become closer to real world if it could modulate the load to show spikes and troughs as opposed to running a consistent throughput profile. Lastly, it's rare to see 100% gets or 100% sets in a key value cache workflow. We would love to see a set get ratio to see how the system reacts. At Momento, we typically do our testing using RPC perf. It is written entirely in Rust, handles more real world scenarios like 3 features request above, and pairs incredibly well with Resilius. Regardless, even RPC pref is a synthetic benchmark, and even though it gives you more degrees of freedom to simulate production workflows, the result should not be interpreted as generally applicable to every workflow. Small variables make huge differences, and simulations are no match to production. Final thought: performance is a practice. Valkey has not only kept pace, it's setting it. Meanwhile, the performance ceiling keeps rising, but getting there isn't automatic. It requires expertise across system infrastructure and workload behavior. At Momento, we help teams achieve this kind of performance every day. Whether you are running Valkey, Redis, or evaluating your options, we are here to help you scale with confidence. Yeah, that's it. Thank you for watching. Bye.